Welcome to the first video of section 7.2. In this section, we're going to be focusing on graphing rational functions. Now, a rational function is a function that just is in this form. Let me show you. A rational function is a function that is in the form p of x over q of x. This is right from your textbook right here. So a rational function is just a fraction where both the numerator and the denominator are polynomials. Okay? That's the definition of a rational function. It's a fraction in which the numerator and denominators are polynomials. Now remember, we looked at rational expressions a couple chapters ago, and you guys have worked with those. Now we're just graphing rational functions. Now, notice our denominator, q, cannot equal 0. Q cannot equal 0. Otherwise, we'd be dividing by 0, and we would have an undefined value. So one of our rules when we're looking at a rational function is that the points at which make our denominator 0 are going to give us problems. So we're gonna look at what that does. So we talked about inverse and direct variation problems in the first section. If you look at our inverse variation function, a over x, that is a rational function. Now, our numerator is just a constant, and our denominator is just the function x. So it's still a fraction of two functions. It's just a constant on top and a variable on bottom. So when we look at a simple rational function, we look at 1 over x as probably the simplest rational function you can have. So in this problem, we want to graph 4 over x and then compare that to the graph of f of x equals 1 over x. So what I want to do is I'm going to show you on Desmos what the graph of 1 over x looks like. This is what 1 over x looks like right here. Notice as we get a little bit closer right here, you'll notice that I want to point out that we have two asymptotes on this. We've got an asymptote at x equals 0 and an asymptote at y equals 0. Remember, asymptotes are those lines that our graph gets close to but doesn't quite touch. So in this case, we've got, if you look, imagine we have an imaginary line right here on the y-axis and another one right here on the x-axis. Okay, this is our graph. If we zoom in and look closer and closer, our graph is approaching the x and y axis, but never quite touching there. If we keep going in here, you'll notice we get close, but it never quite touches it. So those are our asymptotes. Now, the graph of our simple parent function, 1 over x, this is called a hyperbola. Now, we call this graph is a hyperbola, and it's made up of two parts. These parts are on opposite sides, opposite quadrants of our asymptotes. So notice, again, we're looking at the graph of 1 over x. We have our vertical and our horizontal asymptote, and we have our two branches in quadrants 1 and quadrant 3. Now notice that these lines, again, they approach our two axes, but they never quite touch it. So the domain and range for our function is going to be all non-zero real numbers. Notice, for everything, for all x values not equal to 0, this graph does have a line that goes through. Same thing, for all y values not equal to 0, our second branch here goes through all of our y values, and our first branch goes through all of the positive y values. So what this means is this is our graph for 1 over x, but any function in this form, so any function in the form of a over x where a doesn't equal 0, is going to have the same asymptotes, the same domain, and the same range. So same domain, same range, asymptotes. So your asymptotes are at x equals 0, y equals 0. Domain is all non-zero values, and your range is all non-zero values. So let's go back to our problem. So how to graph one of these. So now that you know what the graph looks like, let's look at how we actually graph it. So in order to graph 4 over x, what we're going to do is we're going to want to make a table. So we know that it's this form, a over x. We know we're going to have asymptotes at x equals 0 and y equals 0. So what we want to do is draw the asymptotes. So what that means is if we take our function, we're going to want to draw our asymptotes right here. And we know that our graph cannot pass through these lines. Now let's go ahead and plug in some values here and we'll make a table. Notice we don't have 0 on here because we know x cannot equal 0. So when we plug in -3, we get -4/3. When we plug in -2, we get -2. -1, we get -4. When we plug in 1, we get 4, 2, and 4/3. So what we want to do is if we look at our graph right here, let's just take these values and go ahead and plug them in. We'll go up on our y value, go up to 4, and we'll go down 2, 3, 4. Now look at, we know when x equals 1, y equals 4, so we've got a point there. When x equals 2, 2. When x equals 3, we've got 1 1/3. So look what we have. We're going to make a line connecting all of these points. So we look at this line, and again, we know that this line is going to approach our asymptotes, but not quite touch. Same thing, let's go look at these values. We've got -1 1/3, -2 and -2, -1 and -4. Again, we know that this branch is going to get close to our asymptotes, but not quite touch. So that's going to look like this. Now, if we look at the difference between our graph and 1 over x, let's go ahead and I'm going to plug it into Desmos for us. So right now, we're just looking at 1 over x. Notice what happens when we change this to 4 over x. Look what happens to our branches. Now we still have the same general shape right here. They still have the same asymptotes and the same domain and range, but it looks like almost looks like we've taken these points right here and stretched them out. Taken these points and stretched them out. All of these points here have just been stretched. So keep this in mind. We're going to start talking about transformations in a little bit. But if we compare, in this first example, if we compare the graph of 1 over x to 4 over x, we see that all of the characteristics are the same domain, the same range, and the same asymptotes. But the only difference that we have is the values are stretched out a little bit. Okay, so when it comes time, so for you to graph, you're going to do the same thing. You're going to plot your points, go ahead and draw your asymptotes, make your table to plot your points, and then connect them all with the 2 branches that go through either side. That's how you're going to graph your hyperbolas and your rational functions.